Some of that information except for the name. I don't know, it made the NA go in the middle of it.
All right, guys, good morning. I still have some exams. Guys, can we bring our attention, please? I still have some exams for people who haven't picked it up, so you can pick that up after class. Today is going to be the final lecture material for the final exam. On Wednesday, we'll review your next worksheet, which I will post later today. And then on Friday, we'll do an exam review, and your final exam is going to be, oh wait, I may have sent myself the wrong one, but I can just grab it. But yeah, so final exam review day is Friday, and then your final exam is going to be on May 1st. It's going to be, the time is going to be a little different. So they usually give 2 hours for the final, so it's going to be 10:20 to 12:20, and it's going to be in this room, and it won't take the full 2 hours. A few notes. I am not going to be able to be here the rest of the week. I have to be with my family. I will try to, or I'm going to do things virtually with you guys. I'm just going to talk to administration. So the next 2 days will be review days. So we'll review things. I will give you like a Zoom or Google Meet link, and you guys can just hop on there and we can go through things and I can answer your questions. Any questions about that? Okay. Tomorrow is your lab practical. Is there any questions there? So I put out a study guide. Did you guys take a look at that? So it's going to be half theory. So it's just going to be, questions that it's sort of short answer. It's not multiple choice. So you should be familiar with, all the different things that I listed in the study guide. And then there's going to be a technique portion. So Dr. Rossman is going to be facilitating the practical tomorrow. She will give you the theory sheet, the one where you just write your answers. Once you finish, you'll turn that into her, and then you'll take a technique sheet and you'll go through and you'll do the techniques. You don't have to wait for everyone else to finish with the theory portion in order to start your technique portion. So when you're done, you'll go up and you'll give it to her. For one of them, she will have to grade it while you are there. It's going to be a microscopy thing. You're going to look at something under the microscope, and she's going to take a look and grade you based on what you show her. So don't raise your hand to show her until you are ready. There's no trial and error like we did in lecture. So you guys have to keep trying to find focus. You've had a lot of practice, and then you'll show her once you have your final image. Does that make sense? Okay, let me, grab the correct PowerPoint. Okay. some reminders there for you. All right, so today we're just going to talk about transmission of infection. It's going to be a shorter, lecture. In microbiology, the first lecture was probably the easier stuff, and so this last lecture will also we're weeding back down, so it's not supposed to be too difficult. But we talked about pathogens and having mechanisms to gain access into the body and being able to persist and colonize and then potentially cause disease. And that disease is when they can exit and transmit infection to new hosts. So we're going to focus on this aspect of pathogenesis. So microbes can be acquired by multiple mechanisms. There's two ways to describe it: horizontal transfer versus vertical transmission. Horizontal is person to person, animal to animal, and vertical is usually when we're talking about maternal to neonatal, so crossing the placenta from the mother to the fetus. Mechanisms of horizontal transmission: it can be direct contact, so you can shake hands with someone and spread, the microbe. So there's got to be actual physical contact from person to person. Somebody sneezes in your face, they're directly, transmitting that microbe. Another way of horizontal transmission is indirect contact. So usually it's when a susceptible person comes in contact with an object that's contaminated, like a door handle, if your benches. That's why we make sure that we 70% ethanol our benches before and after lab. In healthcare settings, really anything can be contaminated with a microbe. And so in the context of touching a doorknob and getting infected, a doorknob is a fomite, so that's usually just what we refer to an inanimate object. So clothing, bedding, furniture, something that's not a biological organism that's able to transmit that infectious organism from one person to the other. So it's an indirect route of transmission. So how do we try to understand and control these disease transmissions from human to human? Obviously, we wash our hands because, fecal oral spread is really important. That's controlled by public health measures. Venereal spread. So basically, you need to know your status. You need to know if you are infectious. Sometimes you can be infectious and not have any symptoms. So it's difficult to control when those social factors are involved. So if we're talking about sexually transmitted diseases, it's important to get tested and know your status. Obviously, we've learned our lesson through COVID. If you have respiratory symptoms, you want to wear a mask, and masks have been tested and verified to really reduce the amount of aerosols that are transferred into the air when you cough or you sneeze. And that's really hard to control, so wearing a mask is really important. Another mechanism of horizontal transmission, we talk about it as being person to person. Inhalation is another one, so via the respiratory tract. So that's transmission via aerosols, or just the droplets of the air and saliva that are in your mouth. So you should basically know that if I were to give you any of these types of transmission, are they human to human? Are they horizontal? Are they vertical? So you guys should know those concepts here. So nothing too crazy difficult. Any questions so far? Yeah, so this is a really cool study that they did where sneezing and coughing without covering your mouth spreads droplets that can be infectious. So over here in the top left, there is somebody that is not wearing a mask. And then this one, I believe this is supposed to be a video. Oh, there we are. So that's a cool video really showing the effectiveness of mask wearing. What is happening? Wait a minute. It'll just go away. Okay. So yeah, this is kind of giving a little more detail into what is actually happening. So there was a lot of data from the CDC that shows that wearing any kind of mask can delay the transmission of COVID-19 better, and that's better than not wearing one at all. So. What are some factors that impact indoor transmission of these airborne diseases? While the motion of the droplets is going to be governed by gravity, the movement is more so strongly influenced by airflow direction and pattern. So you may or not be aware of the fact that obviously there's going to be airflow in your dorms, in your houses, different ventilation types, different air filtration types, how much you clean and disinfect. That is going to influence the aerosol indoor transmission. And so while obviously normally if you were to sneeze, those droplets will eventually kind of move downwards due to gravity, you have to take into consideration that there's airflow and air movement, and how you control that will help affect the airborne transmission of some of these diseases. Another mechanism is ingestion. So the F diagram is basically fluids, fingers, flies, or fields or doors. So feces, food, there's a lot of F's there, but basically you can ingest organisms from your hands, from things you drink, just from, breathing the wrong thing. So that's ingestion, and that would be horizontal transmission. The thing here that makes this different from an airborne or aerosol disease that might, affect your lungs, this ingestion is going to eventually go to your GI tract. Fecal spread, I'm sure you guys, we've talked about this a little bit, but this is kind of an FYI, but this is an E. coli. E. coli we talked about is something that is normal, it exists in our feces. That's what we were trying to test for in the water samples we washed in the hand washing experiment in lab. Speaking of, what were some of the conclusions that you guys came to last week? There was 3 groups: regular soap, antibacterial, and antibacterial with a surgical scrub. Yeah.
Just the normal antibacterial without the scrub.
Worked the best, right? Yeah. And then did you guys see any like fecal contamination, any growth on the red plates, the EMB? Yeah? Great. That tells you what's on your hand. Okay. There's this type of infection called Giardia lamblia. Actually, the infection is giardiasis, but the actual organism that causes it is Giardia lamblia. It's a parasitic intestinal infection, and it can infect dogs, beavers, sheep, humans, just vertebrates in general. And this is usually transmitted from like your lettuce. That's why it's important to wash your veggies from the grocery store, because when you don't, there's potential for these cysts to be there. So because it's a parasite, it forms these cysts that can run through water and survive in the water or on the lettuce or veggies. So this is one of those that is transmitted via the oral route. So this is an example of the ingestion, and the cysts essentially can survive, so you really want to make sure that you clean your veggies. It spreads really easily. It can occur in daycare centers, but it's a parasite, so you guys should know that. Okay, so just kind of going through a summary of these, there are routes that can be from the saliva, your respiratory tract, your GI tract, your genital tract, skin, milk, blood. So those are routes of transmission, which means where you are transmitting the infectious disease from. And then there's another term, this is more so terminology in epidemiology that you guys should know. There's a route of acquisition, so acquiring the organism. So that can also be any of those routes, plus even your conjunctiva, so your eyes. And so in order for a disease to occur, the route of transmission has to match up with the route of acquisition, as well as the infectious agent's mechanism of infection. And so it's kind of formulaic in you know, it's very easy to catch things, but it's actually pretty formulaic in terms of what needs to happen. So if I, you know, sneeze and Jessica's right there, but she's far enough so that she can't access or come in contact with my aerosols, then she might not get sick. So the route of acquisition has to be there, and you know, the mechanism of infection has to also be there to occur. So if the infection is supposed to get into your GI tract, then it's got to be inhaled and ingested through your mouth and GI tract. So those three things are dependent on each other. Another thing that you need to consider is the dose of infectious inoculum. That's a really critical variable. How, you know, like I mentioned in Giardia lamblia, I probably didn't say this, but it takes as few as 10 cysts to be infectious. So that will affect things. How much of the organism needs to be there? What concentration needs to be there for it to cause an infection? Okay. Real quick, in epidemiology and trying to control infection, we have this R0 or R0 number. It's a reproductive number. Basically, it is the average number of people who will contract a disease that can be transmitted from one person with it. So if the RO is 1, it means that someone with the virus or disease will pass it on to one person. If it's 2, then each infected person will pass it to 2 people, who will then give it to 2 more people, and so on. So the larger the RO number, the more people can be infected. So if the number is greater than 1, the number of people with the virus will rise. If it's less than 1, then you know it's going to decline. So that's one of the ways that epidemiologists try to control infection. For COVID-19, the R0 is estimated to be around 4 to 7. So that's a pretty high R0. But here are some other ones with even higher numbers. So the only one you need to know is the one for COVID-19, SARS-CoV-2. But just to give you an idea of other infectious diseases and how we apply this reproductive number to our infection control. So. All right, that is all I have for you. You are officially done with all the material for microbiology. Congratulations. Remember, on Wednesday, we'll go virtual, we'll review the last worksheet, and then on Friday is the exam review day, also virtual. I'll be in contact with that. Please check Blackboard for updates. Yeah, so you should just do like 3 types of bacteria, right? Or you can be vegetarian. Know what they show you. Yeah, that could work. I'll be leaving 4 today. I'm not your but yeah, I know the kids are doing like that much before that or something like that.
Could I just get my exam 3?
Yeah.
And thanks. Do we get our lab notebooks for tomorrow or no?
To use? Good question. I want to say no.
Okay.
Yeah.
Thank you. That was my question too.
Yeah. I'll make lab notebooks okay tomorrow. You guys can use your lab notebooks tomorrow. I'm not going to complicate it.